So this is your technical leadership team of the ONF, and they set the technical directions. So all these projects you've heard about, all these projects are really cool in deployment now at scale, as you heard this morning. Excellent projects, and here are the people who are really important that you should lobby if you want your project, accepted. Here are the people that you should speak with. And what we're going to do today is break this into two parts. We'll talk about projects in production first, and then we'll talk about how we push the envelope and go forward from here. So what I'm going to do is start by talking about upcoming deployment, already deployments that you heard about, and trials. And we'll start with the obvious one that you heard about this morning. We'll start with Trellis. Why not, right? So Lou, you want to talk a bit about Trellis in production?
Be happy to, Roy. Good morning, everyone. I guess Comcast officially made the announcement today, but we've actually had live customers since last year. ONF last year we had first started. So we've had some stops and starts, but for the most part, 2019's been very successful. We have a demo in the hall where we're showing 120,000 routes, and that's in our pre-production environment. We have multiple environments there, and at our partners as well. I think that's key to the success, is that everyone's really has the same set of test equipment and can see and duplicate problems as they arise in the field. But our goals for the rest of the year are to get to 150,000 routes with what we consider, what we're calling our F4 reliability, the ability for the network to handle either a hardware failure or what we see quite often are host moves. So we virtualize the CMTS. It's on commercial off-the-shelf hardware. There's redundancy associated with it, but with moves and pods moving from one server to another, it puts stress on the controller. So we're continuing to work on ways to optimize controller performance. And we certainly see a path to 150,000 routes with reliability. Today in production, we're sort of guarding against problems. So we're really running at 50% of the capacity we can achieve in a lab environment. We want to get to that 150,000 routes and realize the costs that we anticipated with the project.
Got it. Excellent. Very good. And obviously it's very well understood what's happening there. But maybe let's talk about beyond Trellis. Maybe Bora, you want to share a little bit about something that's not Trellis? Maybe Volta or Seba?
Yeah. We'll be happy to do that. So this is Bora Eliacik from Telekom Netsia. And thanks, Louis, for this great info and update about what Comcast has done with Trellis. Now I'm going to talk about Telekom and Seba, which actually is the next ONF project that will hit production soon. And actually, to do so, I will share with you guys a short video, and that clicker will be helpful to start.
There was a reason I had the click in my hand. let me try and see if that works.
So actually, the video will show you the overall topology of the actual deployment that we have in the Telekom network, and it will take you through the whole life cycle, including remote deployment of the sites, as well as automated tests for validation of those installations. And it will also depict the service provisioning as well as service consumption. And whatever you are going to see as UI and videos of the actual sites and actual systems.
And can I ask how many sites are you planning on taking into production soon?
Yeah. I'll just explain it right after the video.
Right after the video?
Yeah.
We could keep the music track going right through the whole session.
So the actual data center, what we call the live lab, that is connected to live network of Telekom. this is the topology view after the sites are installed and validated. And you can mix match OLTs and ONTs from different vendors that has already been tested. And the service provisioning and activation is done remotely. And as you might be able to see, it's a triple play service that is being provisioned.
I like its knock, it's pretty cool. It's got blinking lights on one side and different lights, cool music. It's a good knock.
Yeah.
I like that.
So it's a Jenkins music.
Jenkins music, yeah, why not? Maybe Seba music we can call it.
Gonna open source that too?
Why not? So these are the actual screenshots from the service consumption for the internet and voice over IP that is connected to the IMS production. And this is the IPTV multicast. So yeah, that's that. I hope you liked it. Actually, with a pace of 1 million homes passed per year, Türk Telekom is serious to take Seba into production by the end of this year. With triple services, namely high-speed internet, IPTV multicast, and voice over IP. With basically 2 sites, 1,000 users each, and with also real paying customers that will make this be the first commercial deployment of Seba.
Nice.
So let me take this opportunity to thank to the Seba community for making this a reality, and thanks for listening.
Excellent. So 2,000 users live very, very soon.
Yeah.
Very nice. Triple play. Very nice. Excellent. Very good. So certainly, commercial deployment coming soon. Excellent. As long as you don't, well, never mind. I'll stop right there. Yeah. Someone doesn't try to up your game, but, like they did with 5G in Korea and the US, but we'll leave that be. Anyhow, all right, let's move on next to Volta and Seba again, but Manuel, maybe talk about deployment plans. That would be helpful.
Sure, yeah, it's a pleasure. So yeah, Volta Seba, much has been said already, and I think we all have seen jointly, right, that there's lots of interest, and that is probably one of the key projects. So that's the same case for us at DT. We're very serious and very interested in taking Volta and Seba to production. So focusing on Volta, we are planning to do so by early next year in Q1 with live customers, and then go for a gradual rollout with FTTH and FTTB. So a lot of solution elements were already addressed in the very nice film or spot here from Türk Telekom. So you just heard Jochen's keynote, and he highlighted how important it is to address operational aspects and consider how this works in production, not just from a technology perspective, but moreover, how you actually operate and run this. So there's still a lot of work to do. We are very happy to collaborate, and actually that is what really makes this all possible in this community. And when we look at how we see this moving forward, we see 3 major solution elements that we are also committed to work on and contribute. One is the enablement of G.fast in Seba. Another important cornerstone, the BNG, Broadband Network Gateway. And there's also opportunity to integrate other access technologies like millimeter wave. In that case, it allows to be integrated into the operator's workflow just as any other access, and so really leveraging this great potential of having a disaggregated and virtualized programmable access network architecture. So that's where the transformation is really happening. We are working on it with others in the community on the reference design, and then also, of course, subsequently on incrementing that functionality in the exemplar platform. Yeah, and so at this point also, thanks very much to everybody who collaborates and contributes, and looking forward to deepen and continue that.
Excellent, very good. All right, on the Volta Seba track, we'll talk to Hank. And so, what's your thoughts, Hank? What's happening?
I think we've been making some huge progress across the industry, and it's really good news in general with access deployment. As has been mentioned, we've kind of got a progression, right? Stuff started with switching and routing. It's kind of moved into the core network, moved out to switching and routing at the edge network, and moving into access. And eventually, that really hard area, RAN, is on the frontier. So, it's a transformation. It's an ongoing phase transformation. Different operators are moving in different speeds and different technologies, largely because we're at different places in the network and different priorities and different sets of products. But the set of folks you see here and in the room overall are making some huge progress and direction. As Andre announced, he mentioned that we've got 500 to 1,000 home trial going on now in using Seba. We've announced in the past that the trials that we've been doing, including this one, are based on XGS-PON. And since I was called out a little bit, or AT&T was called out a little bit this morning, I'm just going to make a couple of comments. Get this out of the way.
All in fun.
All in fun, yeah. At XGS-PON, you can kind of see the products sitting next door in white box capable and multi-gigabit. XGS-PON's kind of a 10 gigabit class technology. Standards work going on in 25 and 50, so the technology and the progress moves ahead, both on the access and technology front across cable and fiber and other technology areas, and on the virtualization front, as you're seeing here. We have a set of very fierce competitors in the room, right? But as Joachim and Chris pointed out, we also have a lot of community going on here. And I am really happy that Trellis is where it's at because that is helping us push the community forward. And if you're sitting on the TLT or the board meetings, we're all kind of pushing for all of these to happen because it is an industry-wide transformation. And one of the things I liked on Chris's slide, I think it said that, I don't remember exactly how he had it worded, but the last bullet on the right-hand side of one of the slides basically said that, I think he said 5G and IoT, and I'll broaden that to other broadband technologies, are improving people's lives. That's what we're doing. To have that keep happening, I think that the technology we're talking about here, the open technology, the open architecture that we're implementing on a piece-by-piece, phase-by-phase basis, that's a key to making that happen and making all those things real. We can't go on without it. We've got compute moving forward. We've got communications moving forward. They kind of work together, and we use each other's parts. And the overall technology virtuous cycle is improving the overall direction that I think we've got in the industry and across the world. If you get the idea, I think this is really important work. That's my view.
Good. Thank you for the passion, and I think that probably speaks for the whole TLT. I mean, that's the reason why you do this, right? So when you're going to follow that up with something more exciting and more passionate.
Okay, yeah. I think from my side, I would like to, quick update with you the latest activity, ODM Project.
Yes. Yep.
And ODM Project is another project that we will discuss today in this panel. And I hope that currently we're still in the trial phase, but I hope that it can be in the production in the near future. But first of all, I have to make a good video with good music first, and bring with you after. But anyway,
yeah, you gotta do that. Let me click. Oh wait, it's not ready yet.
Sorry, yeah, I'm not ready. But anyway, as you might be aware, that NTT is the founding member of the ODM project and have leading the project for several years. And currently, we are doing some trial in this area. And the update from last year is that last year we did some trial on the transponder, but this year we extend the scope to open line system and make it the trial a little bit bigger. And also we get involved some new vendors and partners to the ecosystems, and I think that's a great progress in the past few years. And I think this is a good chance that I would like to share with you another aspect that ONF can bring us great value. So the first of all is that OpenFlow, ONF actually pushed forward greatly the standardization activities, especially in the ODTM project. And we see that ONF's open source activities push forward the standardization such as TAPI interface, open configure interface, and this kind of interface is getting more and more mature and be referenced by different other standardization body and even different technology domain. I think this is a great success. Another, I think, value of ONF that brings us is the push forward the development of open hardware. Actually, we see more and more open hardware are born due to the ODTM project. And I think a great milestone that we achieved last year was the announcement of the collaboration with the TIP community. I think this is a very good symbol milestone that can show people the collaboration between open source, the software, and open hardware. I think that's a great progress last year. Thank you.
Excellent, very good. Guru, anything to add before we transition to looking at the future?
So I think one project that didn't get as much attention, which is also moving into trials and production, is called Omak, which is our open source CUPS compliant EPC. Again, I want to acknowledge Intel and Sprint that actually did the seed contribution, but now it is an open source project within ONF. And there are two operators that are taking it into trials and hopefully production, and one of them is right here. So maybe rather than me speaking for Deutsche Telekom, maybe you want to say a little bit about what you're doing with Omak, taking it to trial and hopefully in production. And you also know about Sprint, so you can talk about Sprint as well. So that is one thing that we didn't cover.
Sure. Yeah,
maybe you can talk about that.
As we talk about future trials.
Yeah, sure. That's a good point. Thanks very much, Guru, for bringing that back. Yeah, there's actually the open source EPC Omak, as you know, that is graduated from MCORD as a component that is right now ready and mature, close to production, ready for deployments. And so T-Mobile Poland is planning to do and bring that into deployment virtually any moment. There are a few last things to do and a few fixes to do, which naturally need to happen once you run a testing phase and want to be absolutely sure that when you switch on for live customers that everything goes well, right? So again, to the operational point, but from a perspective of this platform, this is ready for production, and so this is another very important project here at ONF that can be built on. And so I think we will discuss future opportunities and how to extend and build on top of Omak with regards to Comac soon. But yeah, thanks very much, Guru, for for mentioning Omak. So that is another key area. Yeah.
So Sprint is another operator that is doing trial with Omak.
Yep.
And that is also pretty exciting. So anyway.
No, that's really cool. Mm-hmm. So we've now moved on to sort of trials that are coming up, right? So as opposed to what's in production now. So let's move on a little bit, Omak and Comac, right? So sound alike but very different. So Hank, you're going to talk about Omak, Comac, and ORAN.
Yeah, they're not very different. They're actually related. So.
Exactly.
All right, so one of the things to kind of understand the way we've structured the projects at ONF is that we have reference designs and we have exemplar platforms.
Yep.
The reference design is a high-level architecture, and it basically creates an open modular architecture that's really kind of an essential fundamental principle of what we're doing. Instead of saying there's one big blob that implements the core, one big blob that implements RAN or Seba or a coax network or fiber coax network, whatever, it breaks it into components, says how the components interact, and that's kind of a guiding principle that's really a key part of the agreement. And then we go the step beyond that is to actually build it in open source modules, and we'll build different components. In some cases, you could pull components that are already out there and plug in places in the architecture. In other cases, and in a lot of cases, there's a lot of work that goes on to innovative open source creation among the community to fill in those components and get an overall exemplar system. So Comac is the high-level architecture. And that's really kind of just getting some of the pieces formed, and it's a very long-term visionary architecture. We'll talk a little bit more about that in a minute. And then Omak is actually the first exemplar platform that fits into Comac. So they're different, but they're also pretty closely related in an overall integrated platform way. The bigger picture Comac capability is one of the exciting areas, and it ties into, I think, some of what Joachim was mentioning. It's a move towards convergence. So as we're going into these new open architectures, you're getting an open architecture going on in the wireline, you're getting open architecture going on in routing switching, you've got open architectures going on the gateways, and open architecture going on in the wireless and access and RAN. And that applies across the core network of the RAN, as core network of wireless as well as the RAN. So Comac basically tries to do is putting together a big picture that kind of stitches all these pieces together. It gives us the ability to look at how we can start to converge the core, how we converge parts of the access, how we can take what has been an integrated user and control plane, split them apart, and then actually distribute parts of it in the proper and appropriate intelligent ways. So you can, and then you can actually combine it. So if I'm going to distribute the data plane, essentially the user data plane of the RAN, and also distribute some of the user data plane of the core, I can start to integrate those at the edge, tie it in all with mobile access edge computing, and you can kind of get, this is a big picture scope that we're working on. But it's really exciting technology, so we've got some exciting stuff going on from the near-term perspective and getting it anchored and grounded and being able to do experiments and real-world activities with it, as well as stitching that into this overall big picture architecture. That's one of the things I really find exciting about ONF. ONF started out, if you kind of go back with both ONF and ON Labs, organizations that came together, started out a while ago, and there's kind of like researchy concepts, getting stuff out. It's evolved, it's putting stuff out in the field. We're working through the processes to do that, and we're kind of getting more and more complex and better at that as we actually take this out of the labs and into prototypes, and out of the prototypes and into field tests, and out of the field tests and into production. So the process of making it real is happening here. But it isn't like we've kind of shifted the whole focus, because there's still a lot of really aggressive, innovative, groundbreaking work going on. The Comac architecture is one example. If you were at the sessions that we've had here, you'll see a lot of kind of interesting things that were going on in terms of longer-term aspects. Oz had a talk yesterday afternoon that I really enjoyed that talked about how you apply network slicing and extend it from the network into the RAN and have an open scheduler architecture. So there's a lot of really good, solid, innovative work going on, as well as the hard work of taking this stuff out into the field and into production.
Thank you, Hang. And speaking of end-to-end slicing, Bora, you have some words to add about Comac and end-to-end slicing?
Yeah, there's not much left to say. Actually, yeah, so we see Comac as a natural roadmap to Seba. Seba, will provide the foundation for that, but eventually we'll go forward with Comac. And Türk Telekom, being a multi-play operator, we definitely have an intention to go forward with Comac. But actually, as this multi-access edge cloud gonna be shared among very different networks and applications and users, there we will have a special focus and emphasis on slicing, so that we make sure all of those networks and users and applications operation won't affect each other.
Excellent. Well, speaking of slicing and SDN and all that, Wenyu, anything to add on that front? Or?
Yeah, I would like to share with you something about the different project, new project which relates to next generation SDN. Actually, NTT is joined ONF in a very initial stage. And at that time, we were very interested in open flow technology. And I don't know whether you are aware that as far as I know, NTT was the first operator to adopt open flow into the commercial network. So actually, we are very keen at the new technologies. So we are very keen at the P4 now, and we have already started initial use case studies and initial lab trials. And I think there's two motivations is behind. So first of all, it's very obviously is the cost reduction by using this kind of new technology. And the other aspect is the, we are pursue to create more business, more services in order to create new revenues is by using this kind of new technologies. Two use cases that I can share with you that we are in the investigation is, on the access area, to apply the P4 technology to the to our edge router in the access network. So the first use cases is that we are thinking of to offload some video streaming protocols from the traditional video server to the P4 based ASIC in order to decrease the latencies between the user and the video streaming server. So this is one use case. And the other use case is that we're thinking of offload some traditional network function like PPPoE, L2TP protocols is based on the inside of the edge router area. This is the two use cases that we are seriously investigating at the current moment. And I'm glad that ONF announced that Stratum was
available.
Will go to the open source, will become open source, and we expect that we will receive more and more support from the community and from the vendors, which I think will greatly accelerate the production in the near future. So that's all from me.
Thank you, Wenyu.
Thank you.
Lou, anything to add in terms of the future-looking?
For us, 2.0? I'm part of the technology, product, and experience team, so we're all about improving the customer experience. So with this network, we want to get to 5 nines reliability. We're not there yet, but with some of the things we have on the roadmap, like ISSU for ONOS, and just improved telemetry, predictive failure analysis, we think we can get to that point. And then with this network, we think it's a Ferrari now for this industry, so we're going to add FDX, which is the 10G that a lot was alluding to earlier, and new services like EPON. With an SDN network, we think we can add that quickly.
Excellent, got it. Anything else to add, Guru, before we turn it over to the audience?
Yes, I guess I just want to highlight, when you talked about the Nextgen SDN and Stratum, and you talked about the thing, but I think that is a big deal that I hope people who attended, say, Nick's talk, and then you attended the panel on Nextgen SDN, you understood that with the Nextgen SDN, we are trying to bring 3 or 4 even more key capabilities to network operators. So the value proposition of, for example, if you look at the Nextgen SDN, especially with P4 runtime, what we are saying is that, hey, you as the network operators not only can program your network, you can start with first specifying what is the forwarding behavior that you want from your network, right? And that is what the P4 and P4 runtime lets you do. You decide what forwarding behavior you want. Then you can use SDN principles to program that forwarding behavior with a specific flow tables and all of that, right? So giving you this top-down programming and more control to the network operator. So that is one thing. The second thing is that with whole open config, GNMI, and the combination, we are trying to really enable zero-touch operation. Now, if you listen to Google, these guys have achieved not maybe all the way to zero-touch, but they've come pretty close. And now with these interfaces and these tool chain that we are building, we want to enable that zero-touch operation in the telecom world as well. Okay? The third and fourth thing that was pretty interesting that I don't know people took a note of it, that because of this top-down programming and the way the P4 and all of this does, first time we are going to enable network verification there so that a network operator can be sure that I specify the forwarding behavior, I program the network flows, and when the flows are going through my network, I can verify that every packet is following the path I intended, and it touched only the flow rules that I intended in this box, so that there is nothing that is black box that the operator cannot verify. So these are the capabilities. I mean, Stratum is the foundation and the software stack that we are going to build, but what I hope you all recognize is that that is going to bring the kinds of capabilities to network operators that have not been possible, and that is what we are going to enable. And the good news is that if you look at the demos that are going on, it is not only the Stratum. Stratum is already on whatever, a half a dozen boxes. There is the ONOS implementation that is supporting this. There is the Trellis implementation that is supporting it. There is the BNG implementation that is taking advantage of it. And finally, last thing, I'm sorry, but I want to mention, our DNA, as Hank mentioned, we come from research. We are very well connected still to the top leading institution like Stanford, to Princeton University and Cornell, where there is a lot of exciting work going on in network verification, and that work is now going to show up more and more in our open source platforms and solutions that these operators and others can take advantage of and build on that. So keep that in mind. Sorry.
No, that's excellent.
Just build on a couple of things you said. One thing to emphasize that we kind of heard about the CapEx savings and the cost savings and those kinds of things and equipment directions. But Guru pointed out a couple of other key things that just to emphasize, there's a lot more to a business case than that. Operations and automation are critical, and with the complexity of the environment and the services that we've got, we're not going to survive without taking advantage of that, and that's another kind of key thing that comes out of this work that's essential for all of us and essential for the industry. And the second area is the velocity of introduction of new services, velocity of innovation, the open architectures, the open platforms, the community, those aspects that give what you mentioned as operator control, but I really look at it as it's the opportunity to quickly come up with and introduce and productize innovations to move the network forward at a faster speed. And whenever you're putting together business cases, those are two areas that you can't ignore. They're key aspects for all of us.
Very good. All right. We should probably open up for questions. I'm sure people are dying to ask questions, like Alan here, for instance. Take the mic. Up to you. I think you're equidistant, so the route's the same.
This question is mostly for Guru, stimulated by your remark that 3 universities are doing research projects on network verification. How does ONF engage these universities, and how do the individual members that are on the stage cooperate with them on these research projects to bring them into reality?
So I guess it is not, we have these connections because where we come from. So some of this happens in the ONF context a lot more naturally and organically, because yesterday or today you saw Nate come and give a talk about the kind of work he's doing on network verification, and he's doing that work in the context of P4 and kind of the SDN. So, and we are very well connected. He leads the P4 organization, so that's a very natural. Nick, Stanford, Nick is the founder of ONF and the SDN. So all these connections are there, and then we just bring that into ONF, and because we bring it into ONF, obviously that is accessible to the operators. They are very aware of that because all of these things get talked about in the TLT meetings and the TSAB meeting, and so it becomes accessible to the community through all these connections. And I don't think there is anything special we do. It's just very natural that is happening.
Manuel, you have something to add?
Yeah, and I just wanted to add another example. It's not just Stanford. I think ONF as organization, as open source community, is very open to every contribution.
Oh, yeah.
So we actually worked in a collaboration with TU Darmstadt to develop a P4-based PPPoE BNG implementation. So a prototype code, obviously, so that it's not yet production grade, but it laid one of the foundations for, I think, this demo that is now running next door. And so it was submitted to the community, and the close collaboration with the university here was just another example of having people that can look at this code, look at this community, and just openly collaborate. So there's no closed door or nothing where people cannot really leverage it. And also on mailing list, you do see a lot of students coming up who are doing testing and prototyping. So that is really great. Also looking forward to encourage innovation. Yeah.
Got it. Thank you. Yes, Wenyu.
I want to add one more point. I think people talk a lot about production deployment here, but I think another value that ONF can bring us is actually ONF is creating a platform. So beyond the platform, we can create new functions, new services, and to trigger the new innovation. I see lots of research and some new services is added by researchers is onto the platform and contribute to the open source. Then open source becomes stronger, and then they can be used to do new research. I think this is a very good circle. That open source production, open source research. I think that's another value that we have achieved so far.
Got it. Any other questions for the TLT? These are the people who determine the fate of the projects. You must have a question for them. Go ahead. Or you can just ask. I can repeat the question if you want.
So what can the community do to expedite the adoption and deployment of 5G?
Okay. So what do you think the community can do to expedite the adoption and deployment of 5G?
So
Deploy Omak at home. No, I don't know.
well, there are parts of that. So, all right, so I think the way I look at it is that 5G is going to get adopted and deployed, right? There's a lot of energy behind it around the globe. There's no question that that's going to happen. I think that what's happening here and how that relates to that is that some of the open technology and the software-controlled technology that we need to run 5G, and the virtualization technology that we're really going to need to run 5G effectively, is being done here. And it's a driver for that technology. Getting it out into the field and adopted in wireline is actually going to help us get it into wireless faster than we otherwise would. Because it's teaching us how to do it. We're learning the operation steps, and it's really kind of that stepwise cycle. The other thing that's going on, I'm also heavily involved with ORAN. And ONF and ORAN are kind of set up in a very compatible way. I talked about reference designs before, so the way I would kind of phrase it, maybe to simplify it, is that ORAN is doing the reference design that ONF is following. If you notice the prototypes that that's being shown on the demos being shown, they kind of follow the ORAN architecture and tie in with the ORAN interfaces. So the ORAN's doing the reference design, and then ONF is contributing to the implementation and the exemplar designs to make that happen and make it real. So both from the standpoint of the general work of virtualization, openness, white box architectures, going first in the wireline, so we're learning so we can transfer it to the more complex and challenging RAN aspects. The work in Comac to put that big picture together, the specific work in Omak that gets us an open source core capability with a modular architecture that kind of fits with the generations that we've got to go in the core. I think that to some extent, pretty much all the work that's going on in ONF is going to help us get 5G out there more effectively, more quickly, and with more capabilities.
Yeah, and I think it's one example of one area where it's not just a single organization, right? It has so many facets. It's so broad in this generation, so that 5G has the multiple pillars, right? And so the ONF community can actually help and actually drive real implementations, open source implementations, and address a number of areas where there's great potential to drive this adoption. And convergence is just another example. So certainly there's collaboration then, or reference to other organizations that do specifications of reference designs like ORAN or Broadband Forum or 3GPP. So we do need not repeat or do that all within ONF on our own, but it's about looking at the working implementations where it makes sense to speed up in context of SDN and programmability, and then leveraging the platforms that allow disaggregation and drive open innovation.
Thank you. Any other questions? If not, we have lunch coming up, but I have one difficult question I was going to ask earlier. But so you're sitting on a TLT, right? So it's going open source, we all know that. So you're sitting there with your hat on ONF, and then you have your carrier hat that's paying your bills too, right? Project comes up as TLT. You look at the project and you say, oh, it's in an area of differentiation for us potentially, right? Because at some point you have to differentiate, you're going to make money. I mean, you don't directly compete for the most part, the ones sitting here, but say it was AT&T, Verizon, Sprint, T-Mobile sitting side by side. You're all using Omak, Comac, Volta, Seba, right? Project comes along, you're sitting on the TLT, and it comes up and you say, wait, that project maybe is an area of differentiation that we're working on that could bring value to my customers. How do you approach that? We can have lunch. It's up to you.
We haven't, look, I don't think we've,
happened, I guess.
yeah, we haven't run into it.
Well, I think you have to differentiate on service, customer experience, and other things.
Yeah.
The technology, we're all taking advantage of that, and if you want 5G to be ubiquitous, then we've got to drive costs down. So I think as operators, we see the benefits, and we'll win with innovative programming, superior customer service, and just very available service.
Yeah, we're competing. Don't question that.
Oh yeah.
We haven't had to answer that question mainly because there's a lot of common platform work. We're working that common platform work, and as I've kind of mentioned, as we get these common platforms in place, that enables all of us to do things that are going to allow us to differentiate, focus on our particular customer needs and customer directions. So we're building the platform that is going to enable even more competition as we get these into place.
So naturally, the proposals that come in are non-differentiating proposals that are for the common, for everybody's best interest, and that is, I think, right now that's a common practice. So there hasn't been any exception.
Yeah, I think maybe the other way to say it is that you're so early in the process that there's so much to do that just getting the common stuff going, there's plenty to do, and we haven't even hit that yet. When we hit that, there'll be another common platform to build because you offer the next gen, right? Potentially.
I think you're right on that sense. That this, if you kind of look at the progress we've had, just in the openness, this isn't going to stop.
No.
The first stored program control to use a flying spot store, I think they called it, over 50 years ago. Right? And it was a disk spinning around with a photograph on top of it that had dark areas and light areas, and that controlled communication switch. We've come a long way since then, and we're not going to stop. In fact, things are accelerating. So I think there's plenty of room for ongoing innovation, pushing the platforms, pushing into these new areas. Some of the visionary talks we saw from Nick and Amin and Halkar. I mean, it's just. Yeah, we're going to push it and keep pushing it. I think there's a lot of room and a lot of opportunity. It's exciting.
Very good.
I think,
yes,
if I may just say, right, so if you saw the previous presentation from Chris, right, where him making this point that CSPs will have to come together in order to impact the ecosystem, the supply chain ecosystem. And if you look at, either in the ONF board context or when you talk, there is that acknowledgement that we have to work together in order to transform the infrastructure piece of it and transform this industry together, and right or wrong or whatever, right, that individually each one may not have the scale or the muscle like the big cloud provider.
Like Google or Amazon.
So I think that acknowledgement and recognition is there. It's not like some secret, something that people don't understand. People understand that reality very well, and that you see in ONF in action. Because if you look at it, these are the operators and more that are part of ONF that are driving this change forward.
Right. No, excellent. Good. See, we had one semi-hard question, kind of. And now that we've done the hard work, we can all go have lunch. Excellent. But a big round of applause to thank the panelists again. Thank you. Not just panelists, they are TLT, right? So